Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA 2022 Chemistry Paper 1 Foundation Tier from the Combined Science. Now this paper is out of 1 hour 15 minutes long. It's out of 70 marks and it's got 7 questions. And Chemistry Paper 1 topics are atomic structure and the periodic table, bonding structure and the properties of matter, quantitative chemistry, chemical changes and energy changes. So let's have a look at question number 1. This question is about group 1 elements. So what are the names of what are the group 1 elements known as? So they are basically asking for the name of group 1 elements. That would be alkali metals. The answer is alkali metals. 1.2. Figure 1 shows a lithium atom. What is the number of electrons and neutrons in the atom of lithium? Now, here, if I label the atom, we have the neutrons, and the ones with the positive charges are the protons. Protons always have that positive charge. Neutrons, they don't carry a charge, and they both make up the nucleus. So the middle part of the atom is called the nucleus, and you have the electrons here, and these lines are the shells. Now, what is the number of electrons and neutrons in an atom of lithium? So the number of electrons, you have 1 and 2 in the first shell and the third in the second shell. So we have 3 electrons. The number of neutrons is the 4 dark circles. So that's 4 neutrons. What is the relative charge of a lithium ion? Now, a lithium ion, remember, an ion is an atom that has lost or gained an electron. So atoms that have lost or gained electrons. Now, because lithium is a metal and it has only 1 electron in the outer shell, which is this, it will lose that electron. Now, if it loses that electron, it will have, electrons have a negative charge and protons have a positive charge. Remember that. So in a normal atom, these will cancel off. 3 positive and 3 negative will cancel off. Here, if the lithium atom loses an electron, it becomes an ion, which means it will have 1 more positive charge. So it will carry +1 charge, and we write it as Li plus ion. Question 1.4. Lithium is heated and then cooled in an experiment. Lithium solid goes through stage 1 to lithium liquid and then stage 2 to lithium solid again. So 2 physical changes happen in this experiment. Draw 1 line from each stage to the physical change that happens at this stage. So you're meant to draw only 1 line. So 2 marks for each of the lines. You'll get 1 mark each. So stage 1, it's changing from a solid to a liquid. Now, if you want to change it from a solid to a liquid, you'll have to heat it up, and that is boiling. Actually, no, sorry, it's melting, right? Stage 2, it's going from a liquid to a solid again. So it's actually the reverse. So that would be freezing. Figure 2 represents the melting points of some group 1 elements. So we have a bar chart, and on the y-axis we have the melting point. It goes all the way up to 180. And there's a bar missing for potassium. So what is the melting point of cesium? Oh, pretty sure I have missed a question here somewhere. No, doesn't look like it. Okay. So what is the melting point of cesium? Cesium is this element over here, which is the last element. Now, I would use a ruler to draw a straight line. Find out what that is. Now, between 0 and 10, there's 5 boxes. So if I divide 10 by 5, I will get 2, which means each box is 2. So that means 30 is just one below 30. So that will be 28. So cesium melting point is 28. Right. The melting point of potassium is 63. Draw a bar for the melting point of potassium on figure 2. So going back to the graph, 63 should be about 1.5 box from 60, about there. So if I draw a box, let me bring in a box, and I'm leaving 2 boxes on each side, same way that it was been drawn for this. So you can see for each of the bars, there's 2 boxes on each side. So that's 2 boxes left, and then it's about 1.5. That's should be correct. Now, describe the trend of the melting points for the group 1 elements in figure 2. And I've shown the answer already here. The melting point decreases as you go down group 1, and the biggest drop is from lithium to sodium, not and to sodium. So this first point will give you actually 2 marks, and this second bullet point is actually the 3rd mark here. So describe the trend. So you will have to refer to the information. You can see it's gone from 180 to less than 100, and then it's decreasing, right, steadily, but it's not a bigger drop as before. Question 1.8. The boiling point of sodium is 883 degrees Celsius. What is the state of sodium at 150 degrees Celsius? Now, if it's boiling at 883, that means after boiling, it should be a liquid, right? And it will change into liquid. Now, what is the state of sodium at 150 degrees Celsius? So what are they? So the melting point of sodium melts at 98 degrees Celsius. So sodium is melting at 98. Now, once it melts, it's going to be a liquid, right? According to this, so sodium will melt at 98 degrees Celsius. So after anything above 98 is going to be a liquid. That means at 150, it should be a liquid, right? So it'll be a solid if it's less than 98 degrees Celsius according to the graph, and it'll be a gas above 883 degrees Celsius. Figure 1.9. Sorry, question 1.9, figure 3 represents the electronic structure of a sodium atom and of a potassium atom. So sodium atom and potassium. Complete the sentence. Potassium is more reactive than sodium because potassium more easily gains an electron, loses an electron, shares an electron. Now, similar to lithium, they're all in group 1. So similar to lithium, it will lose that electron in the outer shell, right? All group 1 elements lose an electron from the outer shell to become +1 ion. So potassium is more reactive than sodium because potassium more easily loses an electron, and because the electron is much further away from the nucleus in potassium than in sodium. That brings us to the end of question number 1, which is out of 13 marks. I will see you in question number 2.